Hello, everyone. So today we're going to continue our work with circles, but we're going to specifically look at chords and arcs of circles. So we're going to do a little bit of vocab first so that we have an understanding of what these words mean. And then we are going to get into it. Again, it's going to be a pretty quick day today, looking at the activities, and you'll be all good. So any segment with endpoints that are the center and a point on the circle is a radius. For instance, this has an endpoint here, endpoint on the circle, center of the circle, radius. A segment, that means like a line segment, that passes through the center of the circle is a diameter of a circle. So if this is the center of the circle, this line segment goes from one end of the circle to the other and passes through the center. It is a diameter. A given point is called the center. The point, so the given point, not a given point, sorry. The given point is called the center. The point names the circle. So whatever that point name is, that's the name of the whole circle. So if this point was point J, the circle would be circle J. Any segment with endpoints that are on a circle, so endpoints on the circle, but it doesn't go, and it doesn't have to go through, it's just called a chord. So the endpoints are on the circle, not through the center, it's a chord. All right. So we're going to name the circle one of the radii, a chord, and a diameter of the circle. So the circle is circle O, and you do a circle with a dot in it. That's how you say it, circle O. One of the radii, we could say, is OC. You could have also named OD or OE because they all go from the center to the point on the circle. The chord is chord AB. And the diameter, there's only one diameter, is from E to D because it's from one end of the circle to the other going through the center. Okay. Likewise, we could do the same thing over here. I recommend pausing it and trying it yourself. So this is circle O. One of the radii is OB. You could have also said OC or OA. A chord is going to be ED. And a diameter is AC. Now Q is up here, but it is not in the circle. And it's not specifically not in the center of the circle, but it's not in the circle at all. So it just stays there. Since a diameter is composed of two radii, then D equals 2R, or R equals D over 2. This should be a slight review for you guys. Okay, so now we're going to go through some theorems and we're going to explain them. Within a circle or incongruent circles, chords equidistant from the center or centers are congruent. So for instance, because this right here and this right here are congruent, you can see that it shows congruency because of those lines right there. Then this chord AB is congruent to CD because they're equidistant from the center. Within a circle, so the converse theorem of that is within a circle or incongruent circles, congruent chords, if I'm told A, B, and C, D are congruent, then they're equal distance or equidistant from the center, or centers in congruent circles. Okay. Theorem 2. Within a circle or in congruent circles, congruent central angles have congruent arcs. So if these two are congruent, then these two are congruent. And the converse theorem is within a circle or in congruent circles, congruent arcs. So if these two are congruent, then the angles are congruent. Okay, theorem 3. Within a circle or in congruent circles, congruent central angles have congruent arcs. So if these central angles are congruent, they have congruent chords. Then I have a chord right here that's congruent to this chord right here, and that's the line between AB, not the arc, but the actual line that could be created between AB and CD. The converse theorem saying within a circle or in congruent circles, congruent chords have congruent central angles. So if these are congruent, then the inside angles are also congruent. And lastly, for this page, within a circle or in congruent circles, congruent chords have a congruent arc. So if this is congruent to this, and that's going to be shown with slash marks normally, then this arc is congruent to this arc. Conversely, if these two arcs are congruent, then their chords are congruent. Okay, and again, if you don't remember, congruency means equal. Let's look at the next one. Let's try this out. So the following chords are equidistant from the center of the circle. And you can tell because they're the same, 9 and 9. What is the length of RS? So I need to know the length of RS, which is this right here. Well, if these chords are equidistant, then this chord right here, PR, is equal to RS. And I know that this half from P to Q is 12.5, which means this half from Q to R is also 12.5 because it shows that little one line right there showing congruency. And so this whole side right here is 25. And since PR is 25, RS is also 25. Okay. For this one, we're going to solve for X, which is right here. These two are congruent. We know that. And since these two are congruent, this is 5. This would also be 5. And since this line right here is showing that both chords are equidistant, this is 3.5. This would also be 3.5. That means this chord, X, is equal to this chord right here, which is 5 plus 5, or 10. Okay. We have a couple more theorems. Theorem 5. In a circle, if a diameter, so here's my diameter from A to B, is perpendicular to a chord, here's my chord right here, then it bisects the chord and its arc. What it means by bisects means cuts it in half. So AB is a diameter, and AB is going to be perpendicular to CD. That means CE is going to equal ED, and arc AC is going to equal arc AD because it cuts it in half. Theorem 6. In a circle, if a diameter bisects a chord that is not a diameter, then it's perpendicular to the chord. So AB is a diameter, and CE equals ED. Meaning if this is bisecting it, then these are going to be perpendicular. If AB, the diameter, bisects CD, if it is a bisector, this is like the converse theorem of this, then it is perpendicular. Okay, last one. In a circle, the perpendicular bisector of a chord contains the center of the circle. So if I have a chord right here and I have a perpendicular bisector to it, then that line AB is going to have the center somewhere on it. And here it would be center O. Okay, let's try this out. In circle O, CD is perpendicular to OE. OD equals 15. Let's write that in. CD equals 24. Find X. Well, if CD equals 24 and this is perpendicular, that means it bisects it. So CE would be 12, ED would be 12. And right now we have a right triangle. So we can bring in Pythagorean theorem. X squared plus 12 squared equals 15 squared. X squared plus 144 equals 225. Subtract 144 from both sides. and you get x squared equals 9. Oh, sorry, 81. I skipped a step. Take the square root, and x equals 9. Okay. Example 4. Find the value of x to the nearest tenth. Well, this is the diameter. We have a line coming across. It's 90 degrees. Since it's 90 degrees against this chord, we know it bisects it. So if it bisects it, that means this is 8 and this is 8. This whole diameter is 20, which means this is 10, this is 10. I now have this triangle I can work with, and I can do x squared plus 8 squared equals 10 squared. Remember, the hypotenuse is always what goes in for C. X squared plus 64 equals 100. X squared equals 36. X equals 6. Okay. Now, try and pause the video so you guys can try these on your own. But if you're good to go, let's go. All right, find the value of x to the nearest tenth. All right, so what we can do is this, because it's perpendicular, is going to bisect this. So this half is 4, this half is 4. What I can do is I can set up an imaginary line right here. And because it's going from O to a point on the circle, this is a radius, just like x is a radius. So if I find this hypotenuse, I'll also find x. So I have 3.6 squared plus 4 squared equals x squared, because this is also x right here because they're congruent. Okay, so 3.6 squared, can't do that off the top of my head, so let's go back to Desmos. 3.6 squared is 12.96. I'm going to say right here, 12.96. 4 squared is 16 equals x squared. 16 plus 12.96 is 28.96 equals x squared. Just double checking my math there. We're going to take the square root. So the square root of 28.96, we're rounding to the nearest tenth. So you can either bring up the keyboard or raise it to the 1/2 power like I tend to do, but I'll do this one this time. 28.96, we're rounding to the nearest tenth. So x is approximately, I should do the approximate sign, equal to 5.4. Right there. Sorry, my approximate sign is a little bit wonky. Hey, over here. So x is going to be double whatever this right here is, because it bisects it. If we find this, we times it by 2 and we'll find the whole thing. So I'm going to say that this, I'm not going to put 1/2 x here. I'm just going to put a p here. We're going to find p first and then double it. So 6 squared plus p squared equals 12 squared. 6 squared is 36. 144 minus 36 minus 36. P squared equals 108. Take the square root, and I think it's 10.4. I know I shouldn't know that off the top of my head, but I think I do. The square root of 108 is 10.4. Okay. So now that we have that, P equals 10.4, but I need X. We're going to double that because it's 2 of those. And so X equals 20.8. Okay. Today you are going to be finishing up your, or doing the homework for today's assignment. So look out for that and you'll be sending me a copy of your answers. I hope you have a wonderful day.